Hey everyone, and welcome to today's Explainer. Think of this session as a professional masterclass, specifically tailored for you software engineering students getting ready for your exams. Today, we're going to comprehensively cover Chapter 7. We'll be looking at design and implementation with a really special deep dive into open source development. I am so thrilled to guide you through this material, so let's get our heads in the game and master these concepts together.
Here is our syllabus for today. We'll kick off with an introduction to open source, move into the business perspective, cover open source licensing, summarize Chapter 7 key points, and finally hone in on our exam focus.
All right, let's jump right into Section 1, Introduction to Open Source.
Okay, let's dive into this first major topic by clarifying exactly what open source actually means in the professional software engineering world. To truly grasp this, we need a solid definition. Open source development is basically an approach where the source code of a software system is published publicly online. You see, in the past, the traditional model was to keep code a closely guarded secret. We call that proprietary or closed-source software, and it's usually built by a small, restricted team. Open source flips that old secret model on its head. It invites volunteers from all over the globe to jump in, examine the code, modify it, and improve it as a community.
And this brilliantly illustrates a vital point. Open source is not just some fringe experimental hobby for weekend coders. It is, quite literally, the fundamental backbone of the internet. Think about Linux, Apache, MySQL, Java, Android. These are all open source. Here's a fun fact for you. Even the computers on the Mars rover run on open source Linux. Major, billion-dollar players rely entirely on this collaborative model to run the modern digital world.
So let's do a quick recap of the practical functioning of this model before we move on. First, the source code is published publicly for anyone to see. Second, because there is this massive global community of users, bugs are actually found and fixed much faster than they usually are in proprietary software. But here's a really critical nuance that students often miss. It isn't total chaos. While anyone can propose a change or a fix, successful open source systems still rely on a core group of developers. These folks act as gatekeepers, and they control the final changes to the software to make sure everything stays stable.
Let's move on to Section 2, the business perspective.
So why do companies actually choose to use open source? Let's methodically contrast the benefits and the fears. On the pro side, acquiring open source software is incredibly cheap. In fact, it's often entirely free. It allows for incredibly fast deployment, and, like we just mentioned, that massive user base means rapid bug fixing and high reliability. But on the flip side, companies have some very legitimate fears. They might worry that adopting an open source approach will reveal their confidential business knowledge, their secret sauce to competitors. Furthermore, they might be heavily restricted by the strict rules of open source licenses, which we're going to unpack in just a moment.
Because of those pros and cons, any software company has to ask themselves a few key strategic questions. First, should we use existing open source components to build our product, which saves time and money? Second, should we make our own software open source? Interestingly, many modern companies are adopting a brand new business model. They actually open source their software for free, and instead, they make their money by selling dedicated support and premium add-on services to their clients. It's a real game changer.
And that brings us perfectly to Section 3, open source licensing models.
This is a highly critical topic for your exams, so listen up. Let's start with a major mythbuster. A massive misconception among beginners is that open source means you can just take the code and do literally whatever you want with it. That is absolutely false. Legally, the original developer or company still owns the code, and they apply a binding legal license that places strict, non-negotiable conditions on exactly how you are allowed to use it.
Let's look at the first of the three main models, the GNU General Public License, or GPL. This is what we call a strictly reciprocal license. If you build a software system that uses even a tiny piece of GPL licensed code, you are legally obligated to publish your entire completed system as open source. This is exactly why companies wanting to sell closed proprietary software avoid the GPL at all costs. It would force them to reveal all their secret money-making code.
Next up, we have the GNU Lesser General Public License, commonly known as the LGPL. You can think of this one as the middle ground. If a business is building proprietary software, they can link to LGPL-licensed open-source libraries without having to make their whole software open source. However, there is a catch. If you modify the LGPL component itself to suit your needs, those specific modifications to that component must be published publicly. Finally, we have the Berkeley Standard Distribution, or BSD, and the very similar MIT license. These are non-reciprocal licenses. Honestly, they offer the most freedom to commercial developers. You can basically do whatever you want with the code, including baking it right into your proprietary software and selling it as a closed-source product. The only major rule you have to follow: you must give credit and clearly acknowledge the original creator of that open-source code.
Because these legal rules are so incredibly strict, organizational compliance is absolutely vital. Companies must establish solid tracking systems so they know exactly which open-source components they've downloaded and are using. They absolutely must understand the license types before they even touch the code. And crucially, they have to educate their developers. Think about it. A developer under a tight 2 a.m. deadline might be tempted to just copy-paste some code they found online, completely accidentally breaking license terms and putting the whole company at massive legal risk.
Moving on to Section 4, Chapter 7, Key Points.
Let's pull back for a second and recap everything we've learned in Chapter 7, just to build a complete picture of design and implementation for your upcoming test. First, recall our deep dive into object-oriented design using the Unified Modeling Language, or UML. There are 5 crucial stages you need to remember here. Stage 1, understanding the context and external interactions. Stage 2, designing the system architecture. Stage 3, identifying the principal object classes. Stage 4, developing specific design models like structural or dynamic sequence and state models. And finally, Stage 5, specifying the interfaces so all those components can properly communicate.
We also covered some really vital implementation issues in this chapter. Remember design patterns? That's the powerful idea of reusing accumulated wisdom, like the observer pattern we studied. So you're reusing concepts rather than just blindly copy-pasting code. We also discussed the 4 levels of software reuse to help save on development costs. Then we looked at configuration management, which is that essential practice of using version control systems, like Git, to track versions, code lines, and baselines. And finally, we touched on host target development, where you naturally develop on one machine but deploy the software onto a completely different target environment.
And finally, Section 5, exam focus and conclusion.
So, what's the most crucial takeaway here? It's knowing exactly what to memorize from today's masterclass so you can absolutely ace your exam. Let's distill this down to the absolute essentials. I want you to take a screenshot or physically write down this ultimate cheat sheet right now. You must be able to confidently explain the differences between these licenses. If the exam asks about the GPL, you say it's strictly reciprocal, you must publish the entire system. If they ask about LGPL, you write it's the middle ground, publish only modifications made to the component. And for BSD or MIT, it's non-reciprocal, you can sell the final product as proprietary, just give credit. Memorize this table and you will secure those marks for sure.
Well, congratulations on mastering Chapter 7. You now understand how professional software is designed, how open source development powers the industry, and how to effectively manage implementation. But I want to leave you with a provocative question to chew on. Now that we've designed and built this amazing software, how do we rigorously prove it actually works before releasing it to millions of real-world users? That question sets up our next major topic perfectly. Get ready, because next time we are diving into the fascinating and vital world of software testing. Keep studying hard, and I'll see you in the next explainer.